So we're working through the OpenStax Statistics Chapter 8. We're going to work through the confidence interval exercise that has to deal with the SAR, so it's an absorption rate for cell phones. So you can always access the book for free. You can look in the description of this video for a link, and you can get this Excel workbook you're about to see for free. Go to divideandconquermath.com and go to the OpenStax Statistics section. So for this example, we have that the specific absorption rate for a cell phone measures the amount of radio frequency energy absorbed by the user's body when using a handset. Every cell phone emits radio frequency energy. Different phone models have different SAR measures, so that's your specific absorption rate. So to receive certification from the Federal Communications Commission for sale in the U.S., the SAR level for a cell phone must be no more than 1.6 watts per kilogram. And so we have a table below that's going to show us the SAR level for a random selection of phones. So we're asked to find a 98% confidence interval for the true population mean of the SAR for cell phones. And so we're going to assume that the population standard deviation is 0.0337. Okay, so on the previous tab, I showed how to kind of set up and organize the information here. And so we're going to now use kind of the spirit of the previous tab to influence this. So the first thing that you're going to want to do is you just want to kind of summarize what is the given data that you have here. And this particular example requires a little bit more work. So one thing that you'll notice is it says we have the population standard deviation. So I've got my standard deviation, and again, you just want to continue to notice, is this going to be sigma or is this going to be S? This will start to matter more as we kind of move along in this workbook. So for now, I have just my sigma, that's 0.337. But the two things I don't have, I don't know what my N is and I don't know what my mean is. And so that's because I have to actually now figure it out from this information. So it's easy enough to do, I just have to actually do it. So I am told that this is the data for 30 cell phones. So I at least know, okay, so my N is definitely 30, but I don't know my mean. So what I can do is I can go ahead then and I can just take my average function and I can just select all the data that I was given, bada bing, bada boom, and so there's my mean now. So here's my given data. And now the next thing that I need to know is I need to know what is the alpha that I'm trying to work with. So your alpha is always calculated from knowing what your confidence interval is. So I take 1 minus my 0.98, so that's the confidence interval that I wanted. So my alpha is 2. And so from here, you have some options. So on the previous tab, I didn't do it like this, but I'm just going to show this as another option. So whatever your alpha is, you always need to ultimately divide that by 2. Now, whether you want to specifically call this out or not is up to you. Some people might find it helpful. But so the idea is then from there, I'm going to find my critical value. So just as a reminder, so what does this critical value actually signify? What is it? So the idea is that I have my standard normal curve. And so my alpha over 2, this 0.01, this represents the tail end of each side of the standard normal distribution. So this is the amount of area split in between each tail. This is 0.01 area, this is 0.01 area. And so what I want to know is I want to know what is this z-score here. And so to figure that out, that's where I'm going to use my norm.s.inverse function. And the probability that I use is just that alpha divided by 2. So it's totally up to you if you want to either go ahead and divide your alpha divided by 2, or you could just take your alpha and then notice what I do to the formula. I just divide it by 2, tomato, tomato. It doesn't matter which way you want to do it. So you'll get your critical value. Now, the only other thing with this is that the book has a tendency to round the critical values, so you have to decide if you want to do that or not. And then the other thing is that you always need this critical value to be positive. So I'm going to just show you what that looks like, just in case you do want to do that. So if I want to round this, I'm going to round, and I'm going to take the absolute value of this critical value. So I'm going to take the absolute value of this number, and I'm going to round it to 3 digits. So your book has a tendency to round. A lot of statistics books do, so it's nice to get in the habit of it. So I like to round it just 3 decimal spots. And then from here, what you're going to compute is you're going to compute your error bound. So this is a formula that you are going to want to have memorized, but I just have a quick reference here. So the error bound is always found by taking whatever that z-score is, that one that was where we took our alpha divided by 2. So this z-score times your sigma divided by the square root of n. Okay, so I'm going to just go ahead and calculate that. So I'm going to take this times my sigma divided by the square root of my n. And so there's my error bound. Okay, and so now we can get to our confidence interval. So we have all the pieces now. So what I personally like to do is I like to break this up into the high part of the confidence interval and the low part of the confidence interval. And what the confidence interval is you just take the mean, and for the high part, you add your error bound. And then for the low part, you take your mean minus the error bound. So there's your confidence interval. And I always like to summarize this. The confidence interval is, and then I like to write it out. Just get in the habit that this is interval notation, right? So got kind of everything written out like that. And so now we're good to go. Now, it is possible sometimes you might be like just slightly off on the decimals because of rounding. So that's just something to keep in mind. So, you know, if you, depending on how you round your mean or how you round your critical value, these could be slightly off. So that's maybe just one thing to keep in the back of your mind, but otherwise that's how you approach that one.